welcome to the explainer. Okay, let's be real for a second. If your automated tests are literally taking hours to run, or if you're just constantly battling those incredibly frustrating fleeky test results, you are absolutely in the right place. Today, we're taking a deep architectural dive into enterprise scale testing. Specifically, we're breaking down what I consider to be an absolute game changer in modern automation: Playwright Fixtures. I am so pumped to guide you through this breakdown of how to build a truly resilient, high-speed testing foundation. So let's tackle the elephant in the room right off the bat. Why do legacy test suites almost inevitably collapse when you try to scale them? Well, think of your automation framework kind of like building a house. If your foundation is built on messy global state, cascading failures, and these really rigid, glued-together setups, it's basically guaranteed to crumble the second you add some real weight to it. Traditional testing relies really heavily on your standard before and after hooks, right? You set up a database and a before hook, you tear it down in an after hook. Sounds great in theory, but what actually happens when an after hook crashes? Suddenly, your very next test is totally contaminated. You get this nasty bleeding state, crazy hidden maintenance costs, and ultimately a test suite that you just cannot trust. Which brings us to Section 1, beyond traditional hooks, and into a whole new architectural paradigm shift. There is just a stark night and day contrast between these two approaches. On one side, traditional testing is like this tangled ball of yarn where an afterhook in one file might completely, inadvertently tear down a beforehook in another file. It's chaos and your state just bleeds across the entire suite. But on the other side, we have the Playwright fixture-based style. It's elegant, it's beautifully encapsulated, highly reusable, and most importantly, the setup happens entirely on demand. All right, moving to Section 2, the anatomy of fixtures and how we create these encapsulated testing environments. Let's look at the actual definition here. A fixture is an isolated environment established for each test, giving it exactly what it needs and absolutely nothing else. I always like to visualize this as a fresh, pristine little bubble, or an independent OS process that just pops into existence the exact second a test worker wakes up. And the moment the test is done, pop, it's gone. There's no shared history, no leftover data. It is a clean slate every single time. And guys, these fixtures bring some serious superpowers to the table. They completely encapsulate your setup and teardown into one single place while remaining super reusable across all your files. Plus, because they execute strictly on demand, Playwright only bothers to provision what a specific test actually asks for. Nothing more, nothing less. They're also composable, meaning they can depend on each other seamlessly. Oh, and my favorite part, they completely eliminate the need for those useless empty describe blocks that we all use just to manage environments. Section 3, built-in versus custom fixtures. Let's look at your out-of-the-box arsenal. You know, you've actually probably used fixtures without even realizing it. Playwright hands you this built-in arsenal of heavy hitters on day one. When you just pass the page argument into your test function, Playwright is automatically provisioning an isolated browser page just for that specific test run. The same goes for context, which handles your isolated browser context. Asking for browser optimizes your resources by sharing the underlying browser executable under the hood. Browser name literally just tells you if you're running Chromium, Firefox, or WebKit. And request? That provisions a pristine API request context for your backend testing. Just by naming the argument, bam, the environment is yours. But listen, the real enterprise-level power unlocks when you start building your own. Here is the exact playbook to create custom fixtures, which, by the way, is absolutely perfect for injecting your page object models. Step 1, you use the test.extend function to create a brand new test object. Step 2, you define both your setup and your teardown logic right inside that block. Oh, and quick side note, custom fixture names do have to start with a letter or an underscore. Then, step 3, you just pass that new fixture name directly as an argument right into your test function. Simple as that. Now, I really want you to let this quote from the architecture docs sink in, because this right here, this is the absolute magic of custom fixtures. Fixtures encapsulate setup and teardown in the same place. Code before await use is setup, code after is teardown. The use function is just this brilliant dividing line. Playwright actually guarantees that any code you write after await use is going to execute, even if your test catastrophically fails right in the middle. So need to delete a test user from the database or close an API connection? Just drop it after use and your teardown becomes completely bulletproof. And it actually gets better. Playwright is so flexible that it allows you to just override existing fixtures entirely. You can take standard base fixtures like page or test option storage state and completely replace them, or use dependency injection to tweak them on the fly. For example, say you want to override the page fixture so it automatically navigates to a specific base URL before the test even thinks about starting. You can do that. You are completely in control of the standard behaviors. Okay, section 4, mastering scope and execution, because we really need to talk about scaling performance. Real performance scaling requires intelligent scoping. So let's break down the difference between test-scoped and worker-scoped fixtures. Test-scoped is your default setting. The fixture is set up and then torn down for every single individual test. But what if you need to boot up a heavy Express server or establish a massive, clunky database connection? Doing that per test is going to literally take forever. Instead, you use the tuple syntax, scope equals worker. This neat little trick tells Playwright to set up the fixture exactly once per worker process, sharing it super efficiently across all the tests running on that specific worker. Which brings us to a really important number, 1. See, slow setups can cause nasty, unpredictable timeouts. So Playwright actually grants each worker-scoped fixture its own separate, dedicated timeout. And that timeout is equal to the default test timeout. It's a genuinely brilliant architectural decision because it prevents a heavy initialization task from eating up your actual test's time budget. It literally saves you from those random, flaky, sweet failures. Let's actually map out the exact chronological execution order of a run here. First up, worker setup happens. Second, any auto worker fixtures fire off. Third, your traditional before all hooks run. Fourth, the auto test fixtures spin up. Fifth, your specific page and test execution finally occurs. And then finally, step 6, the strict teardown phase kicks in. Everything here is strictly ordered and lazily executed based entirely on the specific dependencies your test actually asked for. It's a thing of beauty. And finally, section 5, the magic of automatic fixtures. This is that invisible power I hinted at earlier. So up to this point, we've basically said fixtures only run if you specifically ask for them in the test argument, right? Well, automatic fixtures kind of break that rule. By using the tuple syntax auto true, you create a fixture that is automatically set up for every single test or worker. And it does this even if the test file never explicitly mentions it anywhere. They just run silently right there in the background. So why does this matter? What's the real takeaway here? You use auto fixtures to seamlessly streamline complex test suites. Look at these real-world use cases. You can use them to declare global before each or after each hooks without having to manually redeclare them at the top of every single test file you write. You can create global before all hooks for your workers. Or, and this is incredibly useful, you can use the test info object inside an auto fixture to automatically grab and attach debug logs every single time a test fails. It basically runs invisibly, acting as this ultimate safety net across your entire framework. So as we wrap up this explainer, I want to leave you with a bit of a challenge. Take a hard look at your current test suite. Look at the tangled hooks. Look at the flaky setups. Now, knowing the sheer power of on-demand, composable, and scope-intelligent fixtures that are sitting right at your fingertips, are you ready to refactor your legacy codebase into a truly resilient, high-speed enterprise architecture? The tools are all right there waiting for you. It is time to build a foundation that actually scales.